Welcome back to World Decoder. Today we shift gears from digital warfare to the cold realm of precision mechanical engineering. If our previous episodes were games of psychology and electronics, today we enter the tangible world of heavy industrial machinery. How can a cruise missile, often seen as the pinnacle of superpower technology, be built with such surprising visual minimalism? Despite its simple appearance, this weapon boasts an incredible range of over 1,650 kilometers effectively. Let us decode the Paveh Cruise Missile, a masterclass in the art of lean manufacturing and purely functional aerial design. Chapter 1 begins now. When the first images of the Paveh missile were released, military experts were left in shock. It does not carry the sleek, aerodynamic lines that we usually see on the famous American Tomahawk cruise missile systems. Instead, it looks like a device assembled from square modular blocks, lacking the refined finish of traditional high-end military hardware. But in the world of World Decoder, we look at the raw specifications rather than judging based on mere appearance. This perceived roughness is actually the key to optimizing production costs and increasing flexibility in mass manufacturing and deployment. The modular design allows for rapid assembly and easy upgrades without needing to redesign the entire airframe from scratch. Think of it not as a delicate race car, but as a rugged utility truck built for a specific purpose. The external casing prioritizes durability and ease of fabrication over the aesthetic appeal of smooth, compound curves and expensive composites. This approach allows the weapon to be produced in large numbers and transported easily without drawing unwanted attention from satellites. Storage efficiency is maximized because the square shape allows these units to be stacked densely in warehouses and bunkers. Beneath that rough metal skin lies a sophisticated guidance computer that calculates flight paths with extreme precision and reliability. However, the true heart of this machine is hidden at the rear. It is time to inspect the propulsion system. Chapter 2 explores the power source. To fly over 1,600 kilometers, standard rocket boosters are simply not efficient enough. Solid rocket boosters consume fuel far too quickly, providing high speed but lacking the endurance required for long-range missions. Instead, the Paveh utilizes a highly efficient micro-turbofan engine to sustain its flight path for extended periods of time. Let us decode this technology. This engine is remarkably similar to those found on high-end, large-scale model aircraft jets. However, it has been re-engineered with superior durability and the ability to utilize specialized military-grade jet fuel mixtures. This design choice drastically reduces fuel consumption rates, allowing the missile to cruise efficiently rather than sprint to the target. Thanks to the minimalist design, the overall weight is reduced, allowing it to carry more fuel within a compact body. This is the mathematical sweet spot where low structural weight meets stable engine performance to achieve extreme operational range. The combustion chamber is designed to extract every ounce of energy from the fuel, minimizing waste during the long journey. Air intake is carefully managed to ensure the engine receives a constant supply of oxygen, even at varying flight altitudes. Reliability is paramount. This micro-turbofan must operate flawlessly for hours without the luxury of maintenance during its one-way mission. The exhaust signature is kept relatively low to reduce the thermal footprint, adding a layer of stealth against infrared sensors. Testing these engines involves rigorous bench tests to ensure they can handle the vibrations and stresses of a real launch. It is a marvel of miniaturization, packing the power of a jet into a package small enough for a single person to lift. But an engine alone cannot keep a missile in the air. We must now look at the wings that provide lift. Chapter 3 reveals the camouflage weapon. Have you ever wondered how Paveh is launched from ordinary civilian transport trucks? The answer lies in the ingenious folding wing design, which allows the weapon to hide inside standard cargo vehicles. During the pre-launch phase, the wings are folded tight against the body, fitting the missile into a compact box launcher. This mechanism relies on high-tension springs and locking pins that hold the potential energy needed for instantaneous wing deployment. When the launch command is given, the missile exits the tube, and within seconds, the restraint mechanism is released. A spring-loaded hinge system snaps the wings open, transforming a cylindrical projectile into a stable, flying aircraft instantly. This extended wingspan generates significant lift, allowing the missile to glide on the air rather than relying solely on thrust. Without these wings, the engine would have to work twice as hard to keep the heavy payload from falling. Once deployed, the wings lock into a rigid position, ensuring structural integrity during high-speed maneuvers and strong wind currents. The aerodynamics are tuned for subsonic cruising, prioritizing stability and fuel efficiency over supersonic speed or extreme agility. This design gives the Paveh the ability to maneuver like a small airplane, banking and turning to follow complex paths. Internally, the wings are semi-hollow or filled with lightweight foam, further contributing to the overall weight reduction strategy. With the mechanics explained, we must now understand how this machine survives in a hostile environment filled with radars. Chapter 4 analyzes the flight tactics. Why is the Paveh considered a significant concern for modern air defense systems? The answer lies in its terrain-following capability. Paveh is programmed to hug the ground, flying dangerously low to avoid. It weaves through valleys and uses the natural shielding of the Earth to hide from the line of sight of radars. By combining an inertial navigation system with digital terrain mapping, it knows exactly where every hill and mountain is located. It does not travel in a predictable straight line or a high arc like a traditional ballistic missile would. Instead, it follows the curvature of the landscape, constantly changing direction, making its final destination impossible to predict early on. Over water, it skims the surface, blending into the clutter of waves to remain invisible to naval radar scanners. The onboard computer makes thousands of micro adjustments every second to prevent the missile from crashing into the obstacles it uses for cover. It can be programmed with multiple waypoints, effectively circling around strong air defenses before striking from an unexpected angle. This allows the Paveh to attack a target from the rear or the side, exploiting the weakest points of defense. Operating in silence and darkness, it relies on passive sensors, emitting no signals that could betray its current location. Even satellites struggle to track a small, low-flying object that blends perfectly with the thermal noise of the ground. This combination of low-altitude flight and route planning makes it a formidable challenge for even advanced interception systems. We have seen the engine, the wings, and the tactics. Now let us synthesize these elements into a conclusion. World Decoder concludes that the Paveh is a powerful testament to the philosophy of practical, cost-effective military engineering. The designers did not set out to build a sleek supercar. They built a versatile utility truck for war. It is a machine capable of delivering a heavy payload over 1,600 kilometers with the lowest possible production cost. This economic efficiency allows for saturation attacks, where quantity itself becomes a quality that can overwhelm sophisticated defense shields. In modern warfare, the ability to sustain a long conflict often depends on the cost and availability of munitions. Paveh proves that you do not need the most expensive technology to achieve strategic deterrence, just the right technology. As we close the file on this aerial mechanic marvel, another secret awaits us, hidden beneath the deep blue waves. The next secret is waiting for us underwater. Have you ever heard of mini submarines capable of paralyzing a major strait? Part 9 of our series will take you down to the seabed to explore the Ghadir-class midget submarines. These tiny vessels are designed to hunt in shallow waters, proving that size does not always dictate lethality in war. Join us as we analyze how asymmetric naval warfare is changing the balance of power in the world's most critical waterways. Do not miss out on this journey. Hit that subscribe button to join me as we decode the world together. Thank you for watching. This has been World Decoder, uncovering the mechanics behind the headlines. See you in the next episode. Stay curious, stay informed. Click on one of the videos on your screen now to continue exploring our archives. From the skies to the seas, we leave no stone unturned. Your support drives our research and production of these documentaries. Remember, understanding the machine is the first step to understanding the strategy. We will be back with more soon. Until then, keep your eyes open and your mind sharp. The world is full of codes waiting to be broken. Credits are rolling now. A special thanks to our community for the insightful comments and suggestions on previous videos. Make sure that notification bell is on so you are the first to know when the Ghadir submarine episode drops. We appreciate your time and attention. This deep dive into the Paveh missile is now officially complete and decoded. Science and engineering shape our reality in ways we often overlook. Thank you for exploring this reality with us today. Goodbye for now. We will see you in the deep waters of the Persian Gulf in our next exciting installment. World Decoder signing off. Decoding the world, one story at a time. Have a great day and stay safe.